Welcome to AI in 8 minutes or less, your daily AI update. Today, we're looking at the absolute gold rush happening in the artificial intelligence space right now. But, here's the funny thing about gold rushes. Historically, the people who made the biggest, most reliable fortunes, they weren't always the ones out there digging in the dirt for gold. Usually it was the people selling the shovels. Well, in the AI world, those shovels are compute power, GPUs, and the massive infrastructure needed to build these models. So in this explainer, we're going to unpack a huge shift in how models are being built, who's actually building them, and how decentralized networks might literally be the key to solving a massive global hardware crisis. Okay, let's dive into this. 1.6 trillion. That is the staggering parameter count for DeepSeek V4 Pro. Guys, this is a massive release. To put that into perspective for you, the last biggest open source model was hovering right around 1 trillion parameters. So DeepSeek V4 Pro is a full 60% bigger than the previous record holder. We're not just talking about some cute little chatbot update here. This is a highly capable, heavy-hitting model. But what makes this a real game changer is that they released it as both open source and open weight. That means any developer can just download and tweak the literal brain of the model for their own commercial use.
Section 1. The Open Source AI Boom.
So, DeepSeek V4 Pro is basically undeniable proof that open models are sprinting right up to frontier quality. Now, why should you, as a developer or a business owner, care about this? Simple. It's all about control and protection. Right now, closed models, think ChatGPT 5.5 or Claude Opus 4.7, they're amazing, right? But you are completely at the mercy of the companies running them. If they wake up tomorrow and decide to change their terms of service, hike up their prices, or suddenly restrict your access, your business is basically stranded. High-quality open-source models completely protect you from those arbitrary roadblocks. And because developers crave that control, open-source adoption is absolutely exploding. Just look at this Open Router data from April 2026. Chinese AI providers snagged 45% of the API token share. And get this, just a year before, that number was sitting at a measly 2%. Now, to be completely objective here, Open Router is a developer tool for routing apps, so it's not measuring direct consumer traffic like people visiting ChatGPT. But still, the data paints a very clear picture. Regardless of global politics, the open source community is moving at light speed, and developers are eating it up. Moving on to Section 2, the Great Compute Bottleneck. Building these insanely smart trillion-parameter brains takes an unimaginable amount of computational power, but we've hit a massive brick wall. Geopolitical restrictions mean builders in places like China can't always get their hands on the latest US GPUs. But honestly, even beyond the politics, there is a brutal global chip shortage, slamming literally everyone in the AI space. To really grasp the scale of this bottleneck, just look at this number. $4 billion. That is the estimated price tag for a centralized AI company to build just one single modern data center capable of training today's frontier models. The entry fee to even compete in this race is astronomical. But actually, it gets worse. Having the cash isn't even enough anymore. Even with billions sitting in the bank ready to go, 50% of planned AI data center builds are being canceled. Half of them. Why? Because the global supply chain is completely tapped out. There literally are not enough GPUs and chips physically available in the world to build these massive centralized hubs. So these centralized AI giants are slamming their heads against a hard physical ceiling of hardware scarcity.
Which leads right into Section 3, Decentralized AI with Bittensor.
So the crucial point is, how do we solve a hardware shortage when we literally cannot manufacture the physical chips fast enough? Well, the answer might mean looking completely outside of the traditional data center. We need to look at decentralized networks. And that brings us to Bittensor, which you'll often see tracked by its crypto ticker, TAO. Basically, Bittensor is a decentralized AI network. It uses crypto incentives and validators to coordinate global compute tasks, completely skipping the need for a central corporate boss. Its core idea is beautifully simple. Pay everyday people to do a specific task. And right now, that task is providing compute power. So if you have an idle GPU sitting around, Bittensor lets you securely plug that unused power into a massive global grid, and you get paid for it. So, going back to our selling shovels analogy, this whole concept comes down to coordinating whatever already exists. Instead of trying to scrape together $4 billion to build a brand new facility from scratch and then waiting years for backordered chips, BitTorrent just taps into the hardware that is already sitting there on desks, in server racks, and in homes all over the planet right now. It takes this vast, frankly wasteful amount of idle compute that centralized AI companies just can't reach and stitches it together into one giant supercomputer. And the way Bittensor organizes this global grid is super fascinating.
It breaks the network down into 128 specialized subnets. Think of each subnet almost like its own highly competitive mini AI startup. These subnets battle it out to provide the absolute best infrastructure for their specific niche. So, one subnet might be hyper-focused on offering the best raw compute power. Another might be all about running inference, which is just the actual processing of your prompts, while another completely dedicates itself to AI video compression.
And this brilliantly illustrates that this isn't just some pie-in-the-sky theory anymore. Bittensor is already hitting massive milestones. Just recently, the network successfully gathered enough decentralized juice to build a 72 billion parameter model. A lot of people thought that was straight up impossible on a decentralized grid. On top of that, a really capable model called Venice Uncensored 1.2 was built using compute power specifically sourced from Bittensor's Targon subnet. This is hard proof that the network can actually fuel the creation of competitive models and do it at a fraction of the usual cost.
Section 4. Real-world use. Video OS. Now, we have to be real here. For any decentralized network to actually survive the long game, it can't just be about trading crypto tokens. It has to evolve into a legitimate, sustainable business that provides real-world value. Let's look at a really cool practical example happening right now. Over on subnet 85 of the Bittensor network, they focus entirely on AI video processing. They recently dropped a tool called Video OS. What's wild is they are already partnering with PIP Studios, and PIP's client list includes absolute Hollywood heavyweights like Paramount, Universal, Sony, Netflix, and Amazon. See, right now, a lot of startups claim they can scale AI video, but behind the curtain, it's still a ton of manual human labor organizing all those digital assets.
Subnet 85 is stepping in to replace all that manual grunt work with automated AI agents. Video OS handles the whole workflow. Step 1, the AI agents analyze the raw video assets. Step 2, they decide exactly what processing is required. Like, does this need upscaling, compression, maybe translation? Step 3, they actually process the video by tapping into that decentralized network. And step 4, they automatically scale the final output for these massive content libraries. It's a huge deal because it drastically cuts down the operational headaches and overhead for these major studios.
Section 5. The bull and bear cases. As with any emerging tech, we really need to take off the rose-colored glasses and impartially weigh the massive potential against the very real risks. Let's look at both sides. The bull case for a decentralized network like Bittensor is incredibly compelling. If they win, it's because they prove that free markets allocate global compute way better than centralized planning. They completely bypass the $4 billion data center trap and tap directly into cheap, global compute that's ready to go. It's the ultimate workaround for the hardware shortage. But we cannot ignore the bear case. And the bear case isn't that the vision is bad, it's that the execution is brutally difficult. Trying to coordinate thousands of random computers across the globe to train a cutting-edge AI model without running into massive latency and lag, it's like herding cats. Plus, there are totally valid questions about whether community-run nodes will ever actually be able to offer the rock-solid 24/7 security and reliability that massive enterprise clients demand.
Which brings us to our final thought. The big question you should be asking yourself right now isn't whether open source AI is real or if it's growing. I mean, 1.6 trillion parameter models and exploding API usage have already settled that debate. The real question is, who coordinates this open source future, and where exactly are we in this infrastructure cycle? Are we still in the phase of trying to build the biggest, most expensive data centers on Earth? Or are we shifting toward the decentralized shovel sellers, the ones coordinating the hardware that already exists all around us? It is an absolutely fascinating space to watch. If you enjoyed this, subscribe to AI in 8 minutes and never miss what matters.